Attention is the behavioral and cognitive process of selectively concentrating on a discrete aspect of information, whether deemed subjective or objective, while ignoring other perceivable information. Attention has also been referred to as the allocation of limited processing resources. Attention remains a major area of investigation within education, psychology, neuroscience, cognitive neuroscience, and neuropsychology. Areas of active investigation involve determining the source of the sensory cues and signals that generate attention, the effects of these sensory cues and signals on the tuning properties of sensory neurons, and the relationship between attention and other behavioral and cognitive processes like working memory and vigilance. A relatively new body of research, which expands upon earlier research within neuropsychology, is investigating the diagnostic symptoms associated with traumatic brain injuries and their effects on attention. Attention also varies across cultures. The relationships between attention and consciousness are complex enough that they have warranted perennial philosophical exploration. Such exploration is both ancient and continually relevant, as it can have effects in fields ranging from mental health and the study of disorders of consciousness to artificial intelligence and its domains, of research and development. Contemporary definition and research. Prior to the founding of psychology as a scientific discipline, attention was studied in the field of philosophy. Due to this, many of the discoveries in the field of attention were made by philosophers. Psychologist John Watson cites Juan Luis Vives as the father of modern psychology due to his book De Anima Vita, in which Vives was the first to recognize the importance of empirical investigation. In his work on memory, Vives found that the more closely one attends to stimuli, the better they will be retained. By the 1990s, psychologists began using PET and later fMRI to image the brain while monitoring attention tasks. Because of the highly expensive equipment that was generally only available in hospitals, psychologists sought for cooperation with neurologists, pioneers of brain imaging studies of selective attention. A psychologist, Michael Posner, and neurologist Marcus Rachler. The results soon sparked interest from the entire neuroscience community in these psychological studies, which had until then focused on monkey brains. With the development of these technological innovations, neuroscientists became interested in this type of research that combines sophisticated, experimental paradigms from cognitive psychology with these new brain imaging techniques. Although the older technique of EEG had long been used to study the brain activity underlying selective attention by cognitive psychophysiologists, the ability of the newer techniques to actually measure precisely localized activity inside the brain generated renewed interest by a wider community of researchers. The results of these experiments have shown a broad agreement with the psychological, psychophysiological, and the experiments performed on monkeys, selective attention and visual attention. In cognitive psychology, there are at least two models which describe how visual attention operates. These models may be considered loosely as metaphors which are used to describe internal processes and to generate hypotheses that are falsifiable. Generally speaking, visual attention is thought to operate as a two-stage process. In the first stage, attention is distributed uniformly over the external visual scene and processing of information is performed in parallel. In the second stage, attention is concentrated to a specific area of the visual scene, and processing is performed in a serial fashion. The first of these models to appear in the literature is the spotlight model. The term spotlight was inspired by the work of William James, who described attention as having a focus, a margin, and a fringe. The focus is an area that extracts information from the visual scene with a high resolution, the geometric center of which being where visual attention is directed. Surrounding the focus is the fringe of attention, which extracts information in a much more crude fashion. This fringe extends out to a specified area, and the cutoff is called the margin. The second model is called the zoom lens model and was first introduced in 1986. This model inherits all properties of the spotlight model, but it has the added property of changing in size. This size change mechanism was inspired by the zoom lens one might find on a camera, and any change in size can be described by a trade-off in the efficiency of processing. The zoom lens of attention can be described in terms of an inverse trade-off between the size of focus and the efficiency of processing. Because attentional resources are assumed to be fixed, then it follows that the larger the focus is, the slower processing will be of that region of the visual scene, since this fixed resource will be distributed over a larger area. It is thought that the focus of attention can subtend a minimum of 1 degree of visual angle. However, the maximum size has not yet been determined. A significant debate emerged in the last decade of the 20th century in which Treisman's 1993 feature integration theory was compared to Duncan and Humphrey's 1989 attentional engagement theory. Fit posits that objects are retrieved from scenes by means of selective spatial attention that picks out objects' features, forms feature maps, and integrates those features that are found at the same location into forming objects. Duncan and Humphrey's AET understanding of attention maintained that there is an initial pre-attentive parallel phase of perceptual segmentation and analysis that encompasses all of the visual items present in a scene. At this phase, descriptions of the objects in a visual scene are generated into structural units. The outcome of this parallel phase is a multiple spatial scale, structured representation. Selective attention intervenes after this stage to select information that will be entered into visual short-term memory. The contrast of the two theories placed a new emphasis on the separation of visual attention tasks alone and those mediated by supplementary cognitive processes. As Rastafopoulos summarizes the debate against Treisman's fit, which posits spatial attention as a necessary condition for detection of objects, Humphreys argues that visual elements are encoded and bound together in an initial parallel phase without focal attention, and that attention serves to select among the objects that result from this initial grouping. Neuropsychological model. In the 20th century, the pioneering research of Lev Vygotsky and Alexander Luria led to the three-part model of neuropsychology, defining the working brain as being represented by three co-active processes listed as attention, memory, and activation. Attention is identified as one of the three major coactive processes of the working brain. A.R. Luria published his well-known book The Working Brain in 1973 as a concise adjunct volume to his previous 1962 book How Cortical Functions in Man. In this volume, Luria summarized his three-part global theory of the working brain as being composed of three constantly coactive processes which he described as the attention system, amnestic system, and cortical activation system. The two books together are considered by Homsky's account as among Luria's major works in neuropsychology, most fully reflecting all the aspects of this new discipline. The product of the combined research of Vygotsky and Luria have determined a large part of the contemporary understanding and definition of attention as it is understood at the start of the 21st century. Multitasking and divided attention. See also, human multitasking. Distracted driving. Multitasking can be defined as the attempt to perform two or more tasks simultaneously. However, research shows that when multitasking, people make more mistakes or perform the tasks more slowly. Attention must be divided among all of the component tasks to perform them. Older research involved looking at the limits of people performing simultaneous tasks like reading stories, while listening and writing something else, or listening to two separate messages through different ears. Generally, classical research into attention investigated the ability of people to learn new information when there were multiple tasks to be performed, or to probe the limits of our perception. There is also older literature on people's performance on multiple tasks performed simultaneously, such as driving a car while tuning a radio or driving while telephoning. The vast majority of current research on human multitasking is based on performance of doing two tasks simultaneously. Usually that involves driving while performing another task, such as texting, eating, or even speaking to passengers in the vehicle, or with a friend over a cell phone. This research reveals that the human attentional system has limits for what it can process. Driving performance is worse while engaged in other tasks. Drivers make more mistakes, brake harder and later, get into more accidents, veer into other lanes, and are less aware of the surroundings when engaged in the previously discussed tasks. There has been little difference found between speaking on a hands-free cell phone or a handheld cell phone, which suggests that it is the strain of attentional system that causes problems, rather than what the driver is doing with his or her hands. While speaking with a passenger is as cognitively demanding as speaking with a friend over the phone, passengers are able to change the conversation based upon the needs of the driver. For example, if traffic intensifies, a passenger may stop talking to allow the driver to navigate the increasingly difficult roadway. A conversation partner over a phone would not be aware of the change in environment. There have been multiple theories regarding divided attention. One, conceived by Kahneman, explains that there is a single pool of attentional resources that can be freely divided among multiple tasks. This model seems to be too oversimplified. However, due to the different modalities that are perceived, when the two simultaneous tasks use the same modality, such as listening to a radio station and writing a paper, it is much more difficult to concentrate on both because the tasks are likely to interfere with each other. The specific modality model was theorized by Navon and Gopher in 1979. Although this model is more adequate at explaining divided attention among simple tasks, resource theory is another, more accurate metaphor for explaining divided attention on complex tasks. Resource theory states that as each complex task is automatized, performing that task requires less of the individual's limited capacity attentional resources. Other variables play a part in our ability to pay attention to and concentrate on many tasks at once. These include, but are not limited to, anxiety, arousal, task difficulty, and skills. Simultaneous attention. Simultaneous attention is a type of attention, classified by attending to multiple events at the same time. Simultaneous attention is demonstrated by children in indigenous communities, who learn through this type of attention to the surroundings. Simultaneous attention is present in the ways in which children of indigenous background interact both with the surroundings and with other individuals. Simultaneous attention requires focus on multiple, simultaneous activities or occurrences. This differs from multitasking, which is characterized by alternating attention and focus between multiple activities, that is, halting one activity before switching to the next. Simultaneous attention involves uninterrupted attention to several activities occurring at the same time. Another cultural practice that may relate to simultaneous attention strategies is coordination within a group. Indigenous heritage toddlers and caregivers in San Pedro were observed to frequently coordinate their activities with other members of a group in ways parallel to a model of simultaneous attention, whereas middle-class European descent families in the U.S. would move back and forth between events. Research concludes that children with close ties to indigenous American roots have a high tendency to be especially wide, keen observers. This points to a strong cultural difference in attention management.